Okay, let's practice graphing a few of these trig functions using some of the transformation stuff that we've already learned about. Let's look back at how it changes for some of these graphs a little bit. Something to keep in mind is that tangent and cotangent have a period of pi. So if we have a number next to x, that omega value, we're not going to do 2 pi divided by omega, we do pi divided by omega to find that period. For secant and cosecant, it's going to be the same as sine and cosine. It's that period of 2 pi divided by that number omega. Vertical scalings aren't going to matter quite so much. You can't even hardly see them with tangent and cotangent. We do not call them an amplitude. For secant and cosecant, it's basically just your sine or cosine stretches or compresses, and then your secant or cosecant just follows the same rule of going down to the maximum value of the sine or cosine and then going up to the minimum value of the sine or cosine. So we'll see that here in just a second. Phase shift is still just phi divided by omega, just like it is for sine and cosine, going the opposite direction. The vertical shift, we still kind of have a midline of our graph, and that still moves that midline up or down. And then our asymptotes are also affected just like the period is when we have a number omega in the parentheses. And so if our asymptotes are normally at values of pi, we would have to find those by doing values of pi divided by omega. And if our asymptotes are normally at pi halves, then it would be pi halves also divided by omega, so that 2 times the omega, plus the values of the period, because it's just going to change, just add that. Instead of adding pi, it's going to actually add that smaller value, that pi divided by omega, or bigger if omega is a fraction. Don't forget that that can happen. Okay, let's go ahead and look back at these graphs here. So in this first equation, y equals tangent x plus pi halves, we have a horizontal shift happening, right? So this is called a phase shift. So I'm just going to describe each one. So this one's a phase shift. And it's going to go to the left because it's a plus pi halves. So I really just kind of like to draw these as they are and then move them if I need to. I've got these obvious points in my graph that I feel like I want that to be pi. Computer's not responding to me. Pi and 2 pi, which would mean this one is negative pi. So that would mean that pi halves is somewhere in between. I guess that's 5 grid spaces, so that just cuts that in half, which is a little weird, but it's okay. So if we're going to move pi halves, knowing that pi halves distance is going to be important. So that's why I'm kind of marking that on my graph. Notice that the grids I provided to you aren't labeled at all, so you can honestly label them any way you want to. If you want to be really careful with where your tangent points are, you can, but honestly I'm not going to worry about it too much vertically as long as it has the right basic shape and has the correct asymptotes. So the asymptotes would normally be at pi halves, right? And at 3 pi halves. And our tangent graph would look like this. And it just keeps going forever. I could keep, put another asymptote here to keep that process looking the same if I wanted to. Okay, so that means when I phase shift it to the left pi halves, that these graphs, instead of being at 0, the intercepts at 0 and pi and 2 pi, they're going to move to the left pi halves. So I have this little advantage with what I'm doing because I've drawn it digitally, so I can literally just take those and move them. Move all of my pieces just left pi halves. Well, that's weird. It didn't move the whole thing. I rotated it. Grabbed it the wrong place, I guess. And this one would go over here. Now, if I was actually doing this on paper, it's nice to have those guidelines in to begin with anyway. So just to remind you where they originally were was like in here, and here, and we just moved everything to the left pi halves. So sometimes I like to use colored pencils or just draw lighter with my pencil and then put more pressure on my pencil to draw the actual graph after the transformation so I can tell the difference between the parent graph and the transformed graph, whatever makes it easier for you. Okay, this one, the cotangent, we're just going to move that one down 3. Down 3. All right, go ahead and put my asymptotes in. So for cotangent, the asymptotes are where tangent is 0, so that happens at 0 and at pi and at 2 pi. And our cosine graphs go the opposite direction. So we go through these middle points where the tangent normally has its asymptotes. And then they're going to be in reverse, almost like it's a negative tangent. In fact, honestly, a cotangent is a negative tangent that's been shifted. So, okay, so here's our cotangent. So if we're just going to move that whole thing down 3, it's not going to be an obvious change, but where the little twist is kind of in the middle, the asymptotes don't need to move at all, right? It's just the graphs themselves. The asymptotes, when we have a shift up or down, the asymptotes will stay in exactly the same place. So it's just that middle curvy shape part of our graph itself that's moving to down 3. Okay, let's look at this cosecant graph. So to do a cosecant graph, I like to start with a sine graph. So I'm going to start with y equals sine 3 sine x, I guess. I guess it should be negative 3 sine x. I'm literally going to do exactly the same equation, just with sine instead of cosecant. So put in my key points. It's a negative, it's a 3, so it's going to start at negative 3, and nope, it starts at 0, because 0 times negative 3 is still 0. My bad, I was starting to do cosine. Okay, so our key points at 0 are still going to be 0. Stretching it vertically is not going to change that. So then sine would be going up to 3 and down to 3, but because of the negative, it's going to go down first and then up. I didn't quite put that far enough. Try to go up to that 3 on my grid. Of course, 3 can be anywhere you want it to be. Just make sure you always label your intentions for where points are. So there's our 3 and negative 3. So sine graph. I graphed this exactly as it should be if it was sine instead of cosecant. So now all we have to do is flip it and do the reciprocals. I'm going to change this to a dotted line just so it's kind of out of my way a little bit. Oh, that made my 3's look really weird. And then I know my asymptotes are going to be where the sine crosses the x-axis. So anywhere that sine is 0, cosecant has an asymptote. So there's the asymptotes. And then the graph itself will just go the opposite, like little parabolas in between our asymptotes. Not a true parabola, but similar type of shape. In between the asymptotes for each curve of our sine graph. So there's our cosecant graph. We may want to actually say some things about our cosecant graph, like saying where the asymptotes are. That's something I skipped on the first 2 problems, mentioning where the asymptotes are, where those important details are that have now changed slightly. Like this one, let's do range. Range in particular has changed on this one. So instead of going from negative infinity to negative 1, it's going to go to negative 3. And then instead of from 1 to infinity, it's going to be 3 to infinity. So you can see how our transformation has changed the range of our graph, even though it didn't change where the asymptotes are, and it didn't change the domain. It did change the range. Okay, last one here is the change in the period of the graph. So let's change this to a cosine. And let's graph that as a cosine. So the 2 means 2 cycles where there's normally 1. So if I follow the same scale I did here, then that would mean that instead of having my cosine go from the top to here, now I'm labeling this a 1 instead of counting by 1 instead of 3, just so I'm not quite so short, so my graph isn't quite so short. So I'll have a point here and a point, if this went clear over to 2 pi, let's call this 2 pi and call this pi, it would be at 1 at 0 and at -1 at pi and then back up to 1 at 2 pi. So our graph would go in there. Oh, that wasn't a great graph, but hopefully that makes sense. I'm going to go ahead and, what was I doing? I was going to, it's not letting me save that setting. Oh, I guess I have to click on it first. Change that to my dotted graph because that's not my actual answer. That's just my guideline. And in fact, I haven't even done the 2 part of it yet. All I've done so far is just done my cosine graph. So the 2 in there is going to put 2 cycles where there's normally 1. This time I'm going to go ahead and change to my dotted line before I get started. Change the color. So the cosine with the 2 in there would mean I'm going to have 2 cycles where there's normally 1. In other words, it's going to take the period, which is normally 2 pi. Oh, I thought I got rid of my dots. I switched the wrong thing. The period, which is normally 2 pi, and it's going to divide it by that omega value, which is 2, so it'll be pi instead. Okay, so there's our cosine graph with the 2 cycles in 2 pi instead of 1 cycle in 2 pi. Now all we have to do is flip it around to make our secant. So the asymptotes are going to happen everywhere that there is an x-intercept. So there's an x-intercept there, there's an x-intercept here, and there's an x-intercept. I feel like these should be evenly spaced. I think my sketches may be off a bit. Should be one here, should be one about here. Where should those asymptotes actually be? So for cosine, the asymptotes are normally, let's go look at it really fast. Here's our secant or cosine. So the asymptotes are normally at values of pi halves. But because omega is 2, that's going to change them to values of pi fourths. Wrong screen, back to here. Okay, so the asymptotes, that's probably the hardest part to figure out when the period changes, is that the asymptotes change. So the asymptotes that are normally at pi halves and 3 pi halves are now going to change to, I guess I should follow my own recommendations, which is make sure you write them as equations. So x equals pi fourths, because it's going to take that 2 on the bottom and multiply it by the 2 that's in omega. So it'll be pi fourths, 3 pi fourths, 5 pi fourths, etc. So that's where those green lines are supposed to be hitting, is at all of our pi fourth increments. It's not perfect. Okay, so now to draw in our secant graph. Let's pick a different color. Purple's always good. So that's going to be going upward. This will be going here. This will be in here. And another one in here. And technically another little half piece right here, so that we have our 2 full cycles in 2 pi because of that 2 that has changed our horizontal. This would be a horizontal compression, right? Squished together.